Welcome to EDC lecture 15. Today we'll solve a numerical problem related to fixed bias BJT amplifier. In our earlier lectures, we have studied its DC model and its equivalent AC model using basic components, circuit analysis using basic linear components so that the laws and theorems of circuit analysis, basic circuit analysis theorems can be applied on it. This is the equivalent circuit that we drew in the last lecture, and we studied that how this input side, the voltage at the input side PS, the AC voltage, sees two resistors in parallel. These are RP and this RE junction resistance multiplied by beta if seen on the base side. They appear to be in parallel with each other, and we have this small resistor RS which is from this source, the internal resistance of the source is very small, and in many cases it is negligible. Then at the output side we have this beta IB, the current source is collector terminal, this is emitter terminal grounded, and this is the base terminal. This R0 is the resistance of the collector terminal with respect to ground, it's a very large value. And then we have RC and RL appear to be in parallel with each other because they applied superposition theorem, and this VCC was assumed to be grounded. And this capacitor short circuited, that brings AC, RC and RL in parallel with each other. And then across this parallel combination you find VCAL. So given these values, RB 470K, VCC 12 volt, 3K RC, RL 3K, and beta is equal to 100. We need to find out these quantities. Small re, the input impedance ZI, Zout, ABS, voltage gain stage, and the stage current gain. So let's see. Let's start it by first finding Re. We know that small Re is the resistor on the emitter side to the ground. It appears here from the emitter side to the ground, and in our earlier lecture we studied that it is equal to 26 millivolt divided by IE, where this IE is the DC current flowing through emitter resistor to ground. In order to find IE, we have to perform its DC analysis. We have already studied the DC analysis of this configuration. The DC analysis suggests that the input loop involves VCC, RB, and this base emitter, the voltage base emitter junction. So the expression we derived in one of earlier lectures the expression that we derived in our one of our earlier lectures is IB is VCC minus VBE over RB. If you put these values here, VCC is equal to 12 minus VBE is 0.7 divided by RB 470K. So IB turns out to be 24 microamperes. Once we know IB, we can find IC by multiplying. We can find IE by multiplying this with beta plus 1. This we have already studied, that IC is beta times IP, IE is beta plus 1 times IP. So beta is given to be 101 times IP. This is 24 micro. So IE is 2.43 milli. So when we plug this value of IE here, we find out small re. The small re comes out to be 10.7 ohms. So we have calculated the first desired quantity Re, and we know that Re is a small resistor. It comes out to be 10.7 ohms. The next is Zi. From this equivalent model, we can see that the Zi, the resistance, the impedance seen at this terminal is the parallel combination of these two plus this Rs. So Zi is Rs plus the parallel combination of these two resistors. Since Rs is very small, in our assumption Rs is given to be 0 ohms. So replacing this with 0 ohms, Zi becomes Rp in parallel with beta Ra. Rb is given to be 470k times beta Re. Beta is 100 times Re. We have just calculated 10.7. So Zi turns out to be 1 kilo ohms. What is Zi out? On the output side, we see three resistors. Zi out, we see three resistors. RL in parallel with RC in parallel with R0. R0 in parallel with RC in parallel with RL. Since R out is given to be infinite ohms, very large, so anything infinity solved in parallel with any resistor produces the same resistor. So R out vanishes and becomes RC in parallel with RL. So RC is 3k in parallel with 3k, turns out to be 1.5 kilo ohms. So we have computed, up till now we have computed Re, Zi and Zi out. The expression for ABS was derived by us in lecture 14, our last lecture. The expression is ABS, the stage voltage gain is negative, RC in parallel with RL in parallel with R0, and since R0 is infinity, we don't need to write it, divided by small re. So we have all these values. RC 3k in parallel with 3k divided by 10.7 ohms, just calculated. The answer is negative 140. So this provides us a large voltage gain, 140. The output voltage is 140 times the input voltage. And finally, the last thing to calculate is AIS. AIS is the stage current gain, and in our last lecture we derived an expression for this. In lecture 14 we derived AIS to be equal to beta times RC over RC plus RL multiplied by RP over RP plus beta RP. These voltage order terms solved. So let's put the values. Beta is 100, RC is 3k over 3k plus 3k, RP is given to be 470k divided by 470k plus 100 times 10.7. So it gives us current gain equal to around 50. So this shows there is a voltage amplifier as well as a current amplifier. In upcoming lectures, we will study more amplifiers.